Welcome to the session on order picking of the course Warehouse and Inventory Management. In today's session, we will cover 3 different topics and conclude with some self-study exercises. First of all, we will quickly look into different picking strategies. Second, we will look into heuristic pick paths. And under number 3, we will look into all the heuristics that generate a pick path. Finally, we have some exercises. Similar to most of the other sessions in the course on warehouse and inventory management, these contents are based on the textbook by Bartholdi and Hackman, Warehouse and Distribution Science. This is an open textbook that is available under the web link www.warehouse-science.com, and this means it is for free. Today's session we cover part 3 of the textbook, order picking, and we look into chapter 10, routing approaches to order picking. We have 2 learning goals for this session. If you manage to successfully deal with the topics of this lecture, then first you will be able to discuss the benefits and disadvantages of heuristic pick paths, and second, you will be able to apply one heuristic algorithm by Ratliff and Rosenthal to calculate pick paths by yourself. Let's have a look at different ideas for picking strategies. These are just high-level concepts that we're discussing right now. Though the traditional and classic way to deal with order picking in a warehouse is the approach picker to goods, also called person or human to goods. That means the human picker or the picker moves around in the warehouse and visits the location of the goods that should be picked. Vice versa, the opposite approach is goods to picker. That means there is some technology in the warehouse that moves some of the goods to the human order picker, and the location of the human order picker stays the same during the picking process. For example, we have some conveyor belts, and the conveyor belt delivers a package, a box, to the picker, and inside this box there are different items, and the human picker gets the correct item. One example for this approach is in this YouTube video, which you can click on in the download of these slides. And the third major concept for order picking is to completely automate the order picking process by using robots. Of course, these more automated, partially or fully automated procedures, goods to picker and automated picking, save a lot of time in the order picking process. On the other hand, and they save a lot of human labor costs. So depending where your warehouse is located around the globe, this can save you a lot of money. However, of course, you need to spend money on the technical equipment to automate your warehouse. So which of these 3 approaches is the best heavily depends on the context in which you operate your warehouse, what type of orders are coming in, how quickly they have to be handled, and how expensive the human labor is versus the investment in capital goods. The most common approach is the picker-to-goods approach. And of course, from previous sessions, you already know that the whole order picking process is among the most costly or covers more than 50% of the operational cost of a warehouse. Therefore, it makes sense to have a clear strategy how to do your order picking and to look into ways to make it more cost efficient. So from other courses, for example, operations research or transportation and traffic, you already know the traveling salesman problem. The traveling salesman problem is a famous optimization problem in a transportation context. And the task in the traveling salesman problem is that a salesman has to visit a set of given locations and return to the starting location. And the goal is to minimize the total travel distance of the salesman. This is also a very good basic optimization problem to organize the order picking in a warehouse. Now, most of the warehouse management systems out there, they talk about optimizing pick paths. But typically, they don't really optimize the pick paths because most of the warehouse management systems out there, they do not really have a geometric model of the physical warehouse. They know about storage locations, but these systems often miss the information. What is the difference between the different warehouse locations and what is the physical arrangement of the shelves, of the aisles in the warehouse? So typically there's not a real optimization. Warehouse management systems do not really solve an optimization problem in the sense of a traveling salesman problem, for example. So now assume you have a traveling salesman solution for your order picking problem. That is, you have the concrete information in which sequence, which item should be picked by an order picker in the warehouse. Now, how do you communicate? How do you tell this information to the human? Yeah. Will you give a sheet of paper? Will you use some headset and tell the order picker? It's difficult to communicate this information if you do not have a physical warehouse model. And then the human might have a theoretically clear instruction, but is not able to follow these instructions. Yeah? So our optimization on the computer system is not translated into an optimization of the human picker because the human picker does not understand the instructions. Yeah? So the human picker might know about the sequence in which he should pick the items, but what is the actual path we should follow? It's the same like driving in your car. You know you need to drive to Geotech. When you return from Geotech, you want to visit Muscat City Center and maybe Almush. And maybe you need something to pick up at Samlulu. So which are the actual roads you use to make these visits? Yeah? This is not necessarily clear. And of course, in the warehouse, we face exactly the same problem. And these are some of the challenges. Yeah? So what is the optimal sequence? How do we see a geometric model in our warehouse management system? How do we communicate the optimal sequence to the picker? and which is the actual path that the picker should travel.